All right, so now we're going to take a look at finding zeros from intercept form. And you might be wondering, why are we doing this? We just did this in the last video. And we're going to look at this problem and you're going to see why we're talking about this, because there's something that can go wrong when you're finding your zeros, and indeed when you're graphing from intercept form after you factor. So we're going to start by factoring the problem that's given to us, and then we're going to solve it. So if we're actually going to solve this thing, we're of course supposed to set our y equal to 0. So we now have 0 is equal to negative 4x minus 4x plus 3. But we got to factor this thing. And we're going to go back into our old bag of tricks and say, okay, a times c. What are a and c? A, b, c. ax squared plus bx plus c. So our a here is going to be the negative 4, and our c is the positive 3, giving us a times c is equal to negative 12. Our b value is just this coefficient on b, which is on the x, which is negative 4. So we need to come up with a pair of numbers which multiply to make negative 12 and add to make negative 4. And in my infinite genius, I'm able to say those numbers are negative 6 and 2. If you weren't sure, you would just start with numbers that multiply to make negative 12 and then figure out how you could subtract them in order to make a negative 4. 2 minus 6 is negative 4, or negative 6 plus 2 is equal to negative 4. In any event, we need to split up our middle term now into these two parts. So we have our 0 is equal to negative 4x minus 6x minus 2, or excuse me, plus 2x, because that was a positive 2, plus 3. And as I'm sure you remember, negative 4 plus 2x, negative 6x plus 2x is equal to negative 4x. So we haven't actually changed our equation yet. And now we need to factor by grouping. So we have our two groups, and let's factor. So we can pull a negative 2x out of both of these terms. So I'm going to go ahead and grab those. And that gives me negative 2x on the outside. Negative 2 divided by negative 4 divided by negative 2 is a positive 2, and x squared divided by x is x. Negative 2 divided by negative 6 divided by negative 2 is a positive 3. X divided by x is 1. That goes away. And 2x and 3 don't actually share anything in common. So the best thing I can factor out is a 1. Notice it is a plus 1. And from here, we now need to factor out our greatest common factor, which is our parentheses, which gives us 0 is equal to 2x plus 3 minus 2x plus 1. All right. Now, you might say, well, I factored it. We're good, right? The answer is we're not good. And the issue is that we're not in intercept form yet. And you could still very easily solve for the zeros from this point, but I would much prefer that we actually get this equation into intercept form. And you'll notice that the significant difference between these is that the x values here are just x values. They don't have anything else on them. They're just straight up x's. Here we have a 2x and a negative 2x. So what we need to do is we need to divide each of those coefficients out of our parentheses. So I need to divide both of these terms by 2 to pull it out. And I need to divide both of these by negative 2 to pull it out. And when we do that, our 0 is still out here. We pull the 2 out. We pull the negative 2 out. So they're multiplied out front. 2x divided by 2 is x. 3 divided by 2 is just 3 over 2. Negative 2x divided by negative 2x is a x. And 1/2 divided by negative 2 is minus 1/2. And finally, we just need to figure out what 2 times negative 2 is, and that is negative 4. Now from here, actually solving for our zeros is once again the trivial task that we saw before. In fact, you don't even need to solve for them if you don't really want to. But I'll go ahead and do it anyway. With our x, 0 is equal to x plus 3/2, and 0 is equal to x minus 1/2, minus 3 over 2, minus 3 over 2, plus 1/2, plus 1/2. We end up with x equals negative 3 over 2, and x equals 1/2. So the reason why I wanted to talk about this is because I'm pretty sure that there might be a few instances where some of you are going to be going through these problems and you're going to hit this point before doing the dividing and just say, oh, well, my x values are -3 and -1, not realizing that you also need to factor the values that are multiplied by the x's out in order to get it into our intercept form up here. So getting to intercept form and factoring something are not exactly the same, because if I asked you to factor it, I would just take this thing right here as a solution, what's on the right of the equal sign here. But if I actually wanted it to be in factored form, I would need to see this. Anyway, regardless of where you decided to solve it, you could eventually figure out that our x-intercepts are going to be x is equal to -3/2 and x is equal to 1/2. And this will be a moment when I will also do an aside and say that the zeros of a function and the x-intercepts are the same. There might be some difference. Someone might argue that they're technically different, and one of them is just x equals the x value of the points where the graph crosses the x-axis, and the other one is the actual points themselves. Functionally speaking, they're the same thing. It's just one of them explicitly states that our y values are equal to 0. So our two intercepts here are going to be our -3/2, 0, and our 1/2, 0. And from this point forward, there's a couple of ways you can go to graph it. I'm going to go ahead and use our x is equal to x equals -b/2a to find the x value of our vertex. Now, in order to figure out what our a and b are, I need to go back all the way to the top to fill out these parentheses. So what was our original? Our b was -4, okay. So I'll put that down. And our a, oh, well, that was also -4, how convenient. So that means that for our axis of symmetry, we have -4 divided by 2 times -4. Our -4 is going to give us a +4. And our 2 times -4 is -8, giving us -1/2. All right. Then we need to plug in our x equals -1/2 to solve for the y value of our vertex. And while you might be looking at this and saying, oh my gosh, this sounds dreadful, we are going to go ahead and use the factored form up here in order to plug in the x value, because it's going to come out a lot more cleanly. So for our y, we have y is equal to, we have our -4 sitting on the outside. We have x, no wait, our x value is going to be the -1/2 now. So -1/2 plus 3/2. So I got that from up here. And then the second part is going to be -1/2 minus 1/2. And when we combine our fractions, look at that, they all have the same base. So I can just add the numerators together. When we combine those fractions, we still have our -4 sitting out here. -1/2 plus 3 is at 2, so that's 2/2. This one is -1 minus 1, so it'll be -2/2. AKA y is equal to -4 times 1 times -1, meaning y is equal to a +4. So our vertex will then be -1/2. That's our x value that we spent all that time finding, and 4. And at this point, we have all the points we need to graph this thing. So I'm going to go ahead and put the graph together. And we'll have to be extra careful because we need to use, this is not going to be a huge graph, but I need to be careful about where the points go. So because our x values are each at half points, I'm going to go ahead and make this by halves on the x portion of it. So this is 1. This is 2. These are our x values. This is y. Actually, I realized we're going to need more space on the y-axis because it goes up to 4. So let me extend this a little bit. Our y's. This is going to be 1, 2, 3, and 4, 5. So we have 2 and 4. And then in the negative x direction, we have 1, 2. I got to extend this one a little bit too. That should be negative. Yes, this is -1 and -2. So let's go ahead and plot our points. Okay, so let's go ahead and look at our points. So the first one is going to be a -3, 1. -3 over 2, 0. Excuse me, that was completely wrong. So -3 over 0 is this. -3 over 2 is the same as -1.5, or the midpoint between -1 and -2. So that means our first point is right here, -3 over 2, comma 0. Our second point is 0, or is 1/2, comma 0. Well, 1/2 is right there because it's midpoint between 0 and 1. And our last point is then -1/2, 4. So the -1/2 is right here. We go up to 4. Whoops, it's right over our 4. Let me draw the 4 over here since I've managed to mess up graphing this at every step. This is our -1/2, comma 4. And from here, we have a sufficient number of points in order to put our graph together. So I'm going to go ahead and do it. This one goes down here, goes down like this, and this goes down like this. And we're done. You can add additional points. One that would have been really easy, for example, would have been the y-intercept, which is right here. And then the opposite version of that point as well. But I think that this is adequate to demonstrate graphing and finding the zeros from standard form. But you got to be careful when going from standard form to intercept form, because otherwise you'll end up stopping right here, which could potentially, you'll end up stopping right here, which could potentially end up giving you some trouble.